It's the morning. License confirmation. Alright, looks like my XSplit license is confirmed this time. Very strange, very strange. Alright, let's get started. It's a Monday morning, I'm sleepy as all hell. Once again, I didn't manage to sort myself out this weekend. Yep, I hope the stream's all good. They don't even auto-host me anymore. They don't trust me. Can't blame them. Let's just sort that out ourselves. Best to check. It's good to trust, it's better to verify, as they say. Alright, so. Sort that out ourselves. Oh, no. No. Alright, let's try again on that Watch Me Workplace. And it's disappeared. What? Weird. Alright, that's good. And that should be in some sort of mode that doesn't make any bloody noises. Can I have a no noise mode? Do not disturb. Sounds right. Let's do that. Okay. Let's try it again. Nope. Try this one. Maybe it's still not working. Well, that still doesn't work. Definitely gonna waste a lot of time on stream on that. Hey Polygon, welcome to the stream, how are you doing? Still trying to get set up with Watch Me Work. Alright, looks like the licensing with XSplit seems to have worked itself out. All right. Alright, so we should have our client server networking sorted here. And where's our new tab here? We don't want that. Hey, World in Ashes, how are you? Why is my cam so tiny? It's actually pretty big. It's like, it's about this big. Because otherwise you don't have enough space for the code. That's why. Tiny cam is better than tiny code. Look how much stuff I'm trying to fit on the screen at the same time. It's terrible. Alright. So, where were we? Yes, we were sorting out the hovering from one client to the other. I should get the other mouse, actually, today. Yeah, let me get the other mouse. How do you test two-player games? Of course, by plugging in two mice. Alright. Two mice! Voice. Excuse the morning voice. I pretty much have morning voice most of the time. Alright, so we've got two mice right now. They're playing, moving the same mouse cursor. But with this tool, we should be able to get a second one. Thanks. I hate being hot. I really, really hate it. Okay, so how am I gonna get the second mouse to run a second cursor? If I set up. Alright, next. Well. Shit. I don't know which one it is. Wait, tell you what. Just plug it in again. 3, 2, 1. Plug it in. And ta-da! Come on. Okay. Guess maybe it'll be the last one? Okay. See how that works. Alright, so that didn't get me my second mouse cursor, did it? God damn it. No, that's not it. That doesn't even do anything. We need... Wait, where did it go? No. It just disappeared. Alright, let's try this again. Plural input, right? I guess it's under P. Whoa, this is scrolling very fast. That is one click of the scroll wheel. Are you kidding me? Okay, there's something messed up right now. Here we go. Let's try this again. Oh, wait. Ah, damn it. Now I have these two bad mouse cursors. Shit, there's 3 mouse cursors now. I don't have a third mouse. Uh-oh. Okay, I can still use this one. Uh-oh. That's not good. Plural input, no? The problem is, it doesn't accept right clicks from the oh, no. The hell? Ah. Alright, this is really bad. This is really bad. Something I was worried about, losing control over my mouse altogether. Uh-oh. Uh-oh. How can I control that much? You see, that one goes under the menu because these... Oh, wait, okay. Now this one is that one is that one. Why are there 3? Okay, so... Wait, if I remove this one... Ah, that's that one. If I now do add mouse... Shit, I lose one of those 3. Well, that doesn't really help very much if they're all the same. Idiots. Okay, so one of these 3 is not like the others. I'm guessing the first one then? What would I do if I... Super elasticity. Probably not be in pain every time I wake up in the morning. Damn it, and that closes it, and I lose the second mouse cursor. And that... You see, there's a problem here. So if I unplug this one... That will... Yeah, so that now controls that one. So I have 2 mice. I have that one and that one. So that one, modify. So this one, draw shadow. Thing is, this mouse, like that, cannot interact. So if I remove the purple one, no. No, I don't want that. God damn it. Now I'm back. Do I have to just guess which one is which? Alright, I hope you guys understand what I'm trying to do here. Wait, okay. I'm trying to have 2 mice control 2 separate mouse cursors for an easy way of testing multiplayer stuff. I think I've tried all 3 now. Okay, so I have this one. Okay. So after it runs the setup, it totally screws up. And now I'm back with Mr. Yellow here and Mr. Purple over here. And these two I cannot use to open this. Alright, so then I can unplug one of these, plug it back in, and do I set up? No. Settings. So right now this one is the brown one. So if I click on the brown one, say modify, and just, can I modify selected device? You know what, I can just use that one like that and the other one like that. Problem is, can I hide this one altogether? Because that's obviously not, yeah, that's not really relevant right now. So if I hide this one, then I have this one and this one. And for now, that means I have two cursors. Yeah, this one doesn't work properly though for redirecting. But I can have a cursor here. I really gotta learn how to use a mouse with my left hand. Alright, so the point is, where's that card? We're missing that card here. Yeah, that's the problem. That mouse doesn't actually interact with anything. Okay. Alright, that seems to work. So this one over here, oops, does that. And then this one over here does that. Okay. So we have our test environment. I have this weird feeling you guys aren't here to learn about programming multiplayer games. Alright, so we've got, oh man, I'm gonna have to remember what I was doing here. So, blueprint, client. So the client blueprint, there's some things missing here. We've got this. Okay, card attached. Okay. So the blueprint client listens to card getting attached and then handles the hovering stuff here. And it actually adds hover and unhover on the cards, knowing if they're clients or proxies. Now, if we get it as a message, we know it's a proxy. So we'll set the proxy to true, because it came through the network. Cool. If it doesn't come through the network, we know it came from the event handlers, which are these guys. Where we actually do it, and yeah. So, the same way we're setting up these guys here, we want to manage the drag and drop, right? So we want to have drag start. Right. Now the problem with drag start is that drag start is the beginning of a process and we want to trigger at the end of the process. So drag start lifts the card up. And once the card is lifted, do we want to fire? Right. So, last time we messed around a bit and we added some code that handled that. And the code was based on lifted. Okay. So we have drag start. And we have lifted. Drag start, lifted, drag end, or drag finish. Drag finish. Alright, so drag start, lifted, drag finish, and just drag. 3 a.m. Is my face stretchy? That's where it stops, that's it. I think I just have a big face, like a big cheeks. $3 a.m. So 3 a.m. 3 a.m. You are on East Coast? No. Yeah, East Coast. I'm trying to figure out time. 3. Well, the sun goes this way, right? Or is it the other direction? 3 a.m. 3 a.m. So it's 11 here, so that's plus 15 hours. Shit, man. 3 a.m. Or West Coast. I don't know. Wait. I'm trying to picture the world, right? And the sun is moving over this way. Europe is here, America is here. So 15 hours is more than 12 hours. Is that Asia? I don't know. I don't know. I usually Google this sort of stuff, but that would feel like cheating. Lift it, drag start. So drag start, lift it, drag start. Now the interesting thing is, where is the card in each of these cases? So drag start, card.position.toString, on drag start, on lift it, on drag finish, and on drag. So lift it, card is not defined. Huh. Okay, we can just go this. So drag and drop, drag start, lift it. So the Z is what we care about. Interestingly, drag start happens after freaking lift it. How's that possible? How does... wait a second. Is it because I waited for the timeout? Create card, animate vector, done. So lifted. When does lifted fire? Here. So we got drag and drop, drag start. It fires lifted. So lifted fires during the drag start event handler. It actually preempts it. But it sounds like we don't need lifted at all. So if I just click on here and wait for it to pop up, drag start, the Z is already 300 at that point. Drag start, Z is 300. Alright, so I guess we can ignore lifted, and for drag, let's just do this for now. Boop. Drag and drop, drag start, drag start. We've got our Z's, drag finish, we got our Z's. So if I fire an event here, drag start, and then I listen to the event down here somewhere. Something like this, right? So that comes through as drag start. Now if we get drag start without it going through the drag and drop toolchain here, or the drag and drop helper. So what exactly does it do? Drag start does all of this. Now this we probably don't need. Interestingly enough. Or do we? Because there's no guarantee that this event handler will fire before the other one. I think that's why we use lifted. Yeah, I think that's why we were using lifted. So for now, it's probably better if we use lifted. But only on the client. We actually fire on... We fire drag start over the network to keep it, to ensure the order. Yeah, it's, you know, I double up on the mice. 2 mice. Good morning, Embero. How are you? Alright, drag start. So when we receive drag start, we want to animate it to the lift. So that's the first thing we want to do, is we want to figure out where the possession goes. We want to calculate the lift vector. Get z vector, lift vector. Position sub lift vector. So we want to calculate the lift vector basically relative to the current card. So console.log card.position.toString. That's the current card position. Then we want to calculate message dot I guess position. So what if about we add this like this, right? And then instead of doing it down here, we'll say card.lift. And the message that we sent through has drag start. If we do this, we pass the position through. Alright. And then in here, we fire console.log, bar.info, info, card.lift, position. Now we don't have a toString right now, because this is probably not a proper vector just yet. Then we want to update the position here, card.position.toString. And then we want to say new3 dot vector 3 position dot toString, yeah. Basically. Boom. Card is not defined, line 48. Alright. This.x.toFixed is not a function. Prototype 12. Yeah, okay. 84. Dot copy. And pop it up. What else would I do with super elasticity? I don't know. Probably show off. I don't know what you mean by super elasticity. Do you mean stretchy skin or do you mean flexible joints? Stream keeps hanging, switching from Chrome to Safari. My stream. That's not good. 1 second. I'm not triple dipping like I usually do. Yeah, I just have... nothing crazy going on here. Just XSplit doing its thing. Ah, strange. Maybe because I'm working on pretty... Did I just see 3% CPU usage on my card clients? Ugh, that's awful. Oh shit. Is that like just background network traffic? That could be just the materials? Because I am running dynamic materials. Let's check that out quickly, because that would be awful. 3% CPU, are you kidding me? For the materials? Because I'm running dynamic materials that are re-rendering every frame, and I'm probably doing it in a really bad way. In fact, I know how to get rid of it. I can pre-calculate all of that stuff, actually. I think it's... Load dynamic yeah, if I get rid of these two, it will not re-render the materials. Is that changing the CPU usage here? No, it isn't. What's going on? I mean, the FPS are rock solid, because 3% obviously is not that much. But, if nothing is happening, I would like there to be no CPU usage, not low CPU usage. Interesting. Let's have a quick profile. Both joints and skin. I don't know. I would probably enjoy being less injury prone, I suppose. If you're flexible, you don't... Like, I get sprained ankles a lot. With more flexible joints, they probably wouldn't grind when I move them. Because they're in bits and pieces on the inside. Alright. Setup versus shaders. Wow. Wow. 20%? Are you kidding me? Bind buffers. So it is the materials. I wonder which one though. I don't know if I can tell from here. So glow flow map, alpha value 1, glow flow color. Well, I'm passing 2 of these in. Let me see, I'm using the simple shader and the glow flow shaders, right? And I'm also using the force field material. Glow flow, I think force field material is not in here yet, so. Now the noise map. Create normal material. Do I need, that's for the... Yeah, I gotta be careful. I might be building too much stuff here. Simple vertex and noise fragment. So if we look at those shaders... Where are my shaders? Where are my shaders at? Come on. Shaders. Simple and noise. So the simple shouldn't do much. Yeah, it just passes through the UVs. It does scale them though. That shouldn't be a problem though. And then we have the simple fragment, which just does the mapping, right? Texture. Doesn't even do texture. Wait a second. Texture map. Alpha map. VUVR. Alpha. Alpha. RGB. Glow color. Why does the simple take a texture map? Okay. That's wrong. Now, of course, right now, the effect isn't there. But I guess, actually running the render code is not the problem. Moving the data into the GPU is the problem. problem isn't the problem. The attitude about the problem is the problem. So, at this point, it still uses 3% CPU, right? Maybe I shouldn't worry about that right now. Actually, I probably don't. Can I clear this? Yes. Collect JavaScript CPU for 1, 2, 3, 4. No. Stop. 30%. 26% set program. Render buffer direct. Render objects. Render frame. Set up vertex attributes. Render buffer direct. Render objects. Render frame. Set up vertex attributes. Set up attribute budget. Well, I probably would have to try each shader on its own and see which one does that. All right. I try to focus on the coding. Yeah, live coding, I don't know what they're doing with their player. It's a little bit iffy. Alright, let's not worry about this right now. As Deadliest Seduction pointed out, it is okay to focus on the task at hand. And the task at hand is to figure out how we're gonna transmit the events across and have them work correctly as we want. So, pick up the card, we get lift, and you see we get a slightly different X and Y, and that's because of the Z. So if I do this, the X and Y will be very different. Now, what we want to do is we want to animate it to that position. And to do that, we're going to use more or less this. So we want to calculate the lift vector. Whoa, we don't want to mess up this code. But we want to lift. So, and that's on here. Now the problem is, am I adding this only on the client? Wait a second. But that's fine, because it's attached to all the cards, and it doesn't really care, and the cards are just proxies anyways. So, we don't actually want to do all this stuff. We just want to reference. So the lift vector, so var lift vector equals, so we start with position, and then we'll subtract card.position. I think. And then we'll say lift vector.toString. I think. Well, we'll see. So let's lift it here. And our lift vector is 67. So if we add 67 to that, we get to here. If we add 290 to that. So this is our lift vector. Perfect. So now if we just say card.position add lift vector, and this is fine here. We don't need to use card. We can just use this. Right? Then that should bring the card in line with the card from here. Or not. We got one here. Wait a second. Did I not save this? Why is this not reloading? Very strange. Lift. Yeah. Now, unfortunately, we don't necessarily want to lift it there. We actually want to potentially want to lift it relative to the hover position. Interestingly enough. That is an interesting idea. So instead of lifting it an arbitrary amount, alright guys, what do you think about this? So, I mean, this is obviously generic code that might be used any which way in a future game. But now imagine a game where each player could look at the board with a different perspective. So for example, this player chooses to look at this way, and this player chooses to look at this way. Now, we don't actually care where the card seems to be for this guy, right? For this guy, the card is above, from this perspective, above where he wants to drag it, right? I lift it from there, I drop it there, I lift it from there, drop it there. But it means that the card would appear down here for this guy. For this guy, the guy only cares about where the selection here is, where the card is potentially going to be dropped. You know, this guy only wants to know what the right guy is thinking about. So on the left side, we don't want the card down here, we want the card over here. Right, so let's do something else. Instead of doing this lift vector thing, let's have a quick look at the wireframe, how the wireframe works. So the wireframe is a local variable here. And the wireframe gets removed and added. Create wireframe, attach card, create wireframe. Card mesh. Alright, so we should be able to create a wireframe from the outside, because it just returns it, right? So let's try to create a wireframe just for our own internal use, right? So we have wireframe, and then we'll say if wireframe equals undefined, wireframe equals, now we don't use this, we use the drag and drop, which we have access to up here, right? And then we'll say this dot mesh. Plastic friends. All right. Wireframe. So wireframe is now here. Wireframe just gets put into the local scope. And then how do we make it visible? Scene.add. That's basically all we want to do, right? And it copies the position before the card gets lifted. So in theory, if we do this, right, and I guess scene is accessible up here somewhere, yeah. So scene.add wireframe, and then wireframe.position.copy this dot position. So if I lift this, okay, so that doesn't work because I wrote right instead of wireframe. Fair enough. Wow, that doesn't throw a crazy error. It's one of the main problems of JavaScript. Now the nice thing is that wireframe will pop up under the card no matter where the card is being dragged on this perspective, right? So at the same time, after this has happened, this dot position dot position dot z, and then the z gets set to card drag z. Card drag z. Actually, the lift vector is going to be slightly different. The lift vector is going to be 0, 0, drag z minus this dot position dot z. And I think that should be the lift vector. So the lift vector is 290, right? So now this dot position dot copy or dot add lift vector. So that brings the card up. Pop, right? But, and we might want to, instead of saying drag z, we might want to say, we might want to have two drag z's, right? So let's add a second constant there. Asset data. So we have board z, drag z, and we'll have drag proxy z. And we'll just say that if the opponent drags, we'll drag it at a lower height. So we'll have drag proxy z, right? And then we'll have drag proxy z, drag proxy z. And we might as well card drag proxy z, just to keep things in line. And then we'll say card drag proxy z minus this position. So So that lifts it up, and then after we've lifted, drag start position, position.clone, animate vector. And then we'll just do this. Animate vector, lift vector, right? Okay, now if we make animate vector slower, and I think that's in the animation helper. Actually no, before we go to the animation helper, animate vector gets called from XenoCard 3D, animate mesh, animate vector, wait, animate, okay, I'm confused. So animate vector comes from, okay, does it come from here? Yes, animate vector calls animate mesh. Animate mesh calls animate position, but duration is already settled here. Now the lift duration is really short. So let's just add 1 second to each of those. We should really have a debug flag so we can slow down animations and all that stuff. Boom. Alright. So if I do this here, and then I lift the card here, boop, boop, boop. Alright. CCG. Think Hearthstone. But I'm not just building the game, I'm kind of building an engine. So other people can build games. Because I'm not a game designer, just a programmer. That's why I'm kind of building generic mechanisms. Oh. The current gameplay prototype is still in to-do. Thanks, man. Okay, so we're lifting the card. And now we want to move the card. Now, we don't want to move the card as we're moving it. We want to move the card when the position changes. So we're not actually going to transmit the card position directly, although we could. And we might even, have a little shadowy thing there. But what we really want to transmit is the drop position. So the drop position is calculated by get drop target, right? Now here we're using drag and drop get drop target e this drop z. The problem here is that the drop target, we need the So the drop target is really incorporated as the wireframe. So, get drop target. Target. Alright, so let's use drop vector. Drop target. Target, drop target. And then we'll have target clone. Target, target. Alright. But drop target should really be this dot wireframe is undefined. we should really want to make this accessible from the outside, right? So, how does get drop target work? That's a good question. Does this generate a brand new... it clones the card position, calculates a target through the Z vector, and then it snaps it. I see. Alright, what about if I do this? Define properties. You know what? If I do get rid of this here altogether, and then simply say self dot drop target equals self dot drop target here, drop target, drop target, drop target, drop target, right? And then drag start. We do the same thing. We calculate the drop target. So drop target is E this drops Z. Is that the same up here? Drop target E this drops Z, E this drops Z. So we'll do self.drop target E drops Z, right? Now, drop target drag, wireframe dot position self.drop target, wireframe dot position self.drop target. We can do this here, right? Self.drop target. So the wireframe and the drop target are kind of tied together. Right. So now what we can do over here is, as we move the card, which happens in card dot, let's get rid of this for a sec here. So what we can do actually is on drag start, so card.lift, we want to look at the drop position. The problem is the drop position is on the other guy, so we don't have access to drop position on one of these sides. I'm done stretching my face, man. I'm a serious programmer. Alright. Alright. So we need to pass this stuff through on the events up here. So drag start. What I want to look at here is console.log, drag and drop dot. That's the end of this mix. What shall we continue with? Escape music view mix. Maybe there's something hot in there. Although escape music is probably gonna be just that the whole time. All right. Tropical house. All right, that'll do. Okay, so drag start. We'll look at drag and drop, and we'll look at drop target dot toString. Now at this point, drop target should already have been calculated. So we might actually want to label this. So if I lift this, drag start card.lift, drop target. Now drop target. All right. So if we do this instead, right, and we pass through target instead, right, Then we'll just do this. Drag, start, drag. Let's just say lift. Just to keep things a little bit consistent here. So we want to send lift it. We'll send lift. Right. And then on drag, we're going to just call it move for now. Alright, let's call it drag, but we're still passing in the drop target instead of the card position. Card dot drag. I don't like this because it might interfere with the actual well, fuck it. For now we'll do this and then we'll worry about it later. So card.lift, card.drag. Right. Now the question is, don't really care about the lift vector here. In fact, we don't really care about the lift vector here anymore either. What we really care about is that position that comes through, right? Wait, var drop var target equals position new vector 3 dot copy position, and then we can say target dot to string. Just makes things a little easier. Pick it up, move it. So we got a bunch of drags up here, and we've got lift. Now the lift shows us that position. Okay. So that's our drop position. Now the lift vector will be the target position. Will be target position dot clone dot dot clone lift vector dot z equals card drag proxy z, and then no, that's our target position. That's not our lift vector just yet. We need to subtract the card position to get the actual lift vector. So lift vector dot sub this dot position, and now we want to output lift vector. I believe. Is that it? So lift vector is straight up 90 here. Right. And then we do all of that stuff. So even if I do this, the card will lift straight up and it will only go up to whatever, that proxy z. Now we need to do the same thing over here. So we first calculate our target. Right. Then we calculate our lift vector. Right. Now in this case, most of the time the lift vector will be 0. Exactly. It'll be 0. So we don't really need to do anything. If lift vector dot length actually, let's see if it is dot length, right? If it's really small, don't do anything. Yeah. If lift vector dot length is smaller than 0.001 or whatever. It's greater than 0.01. Then we update the wireframe. Actually, we update the position first. Actually, let's not do this. Let's do this. Only if the lift vector length is greater than 0. So if, as I move it, that will happen once. Interesting. Okay. And then so once the lift vector is there, we want to add the lift vector, or just delta vector. Delta vector. I think it makes sense to use that throughout, actually. It's just the delta. Alright, we'll add that to our position. We update the wireframe, except, no, we don't. The wireframe doesn't go where the card is, which is, yeah. The wireframe goes where the target position is. So, that's just target position. So, drop target. Right, drop target, copy drop target, and then this position dot add delta vector, and then this dot animate with the delta vector, like this. After the wireframe position copy. Cool? And we only do it if we need. Alright. Now there's something weird happening with the selections, because they're not being updated. Alright, now the other thing we want to do is we want to do a slightly different animation. Although, if it's really quick, as it's supposed to be, then you might never even see it. So the animations are supposed to be 0.1 and 0.3, although that might change in the future. So the animate mesh, snap, false, true, true, false. Animate mesh, animate position, and then animate position comes from animate vector, animate mesh. Move vector snap. If snap is true, it does that. If snap is not equals to false, snap is true. So defaults to true. So if I disable snap on those, I basically get my ease in out with a slightly slower thing. So animate vector false. So that will disable the snap. Don't snap, right? Yeah, the only thing is it's a little unstable. Well, unstable as in, obviously you can kind of have it go boop, 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 boop. And you probably, whoa. But the whole point of it is to show the other player what the intention might be of this player. And right now it's not clear because we don't have the shadows enabled. So with the shadows you'd see it much better. And maybe the proxy drag height is a bit too low, so you can barely see it. I gotta look into doing fake shadows as well, because I've noticed that real shadows are a bit problematic on what do you call it, on mobile. That's the data. So if I bring the proxy drag up to 200, so it's not 1/3, it's 2/3, it's not half. Alright, and it means that I can do this. And you see on the right, the card isn't where I'm holding it. The card is just where I'm indicating that it could be. Now the other thing we could do is we could have a small smooth interpolation but instead of using the z vector, we basically just used a relative offset. Like, basically we're interpolating between 0 and 1 being the neighboring positions. Like, we think of these as polygons, and we smoothly interpolate the position. That probably would be the best option. I mean, we do have the information available, right? In fact, not just do we have it available in practice. No, we don't have the actual information available because we're not even transmitting it. Okay, which is kind of good in a way as well. All right, so the next thing is the glow stuff. The glow stuff. All right, so this dot hover. The client glow position. Copy. Client glow. Scene.add client glow. So what we should really do is, we shouldn't do this. And we shouldn't be doing this. We should say client glow dot this dot add client glow. And we should kind of do this dot add proxy glow here. And then on unhover, dot remove, and then proxy glow dot remove. We should actually remove it from the scene altogether. Yeah, the problem is the glow doesn't travel with the mesh. The glow travels with the actual card position. Which means we almost don't need the wireframe. Huh, interesting. So card dot this dot mesh dot add would basically do the trick, I believe. All right, and then the drop. So we'll have lift, drag, and then drag finish. Then we'll just have a drop event. Right. And then the drop event. And to be honest, now that we no longer use the card, we're still using the drag and drop target. The problem is that needs to be calculated before we can do anything. Alright, well, we have drop. I never know in which order I should list them. Lift, drag, drop, or lift, drop, drag. Ooh, that's finished. Oh, that's a short one, 13 minutes. Interesting. Huh. Lonely Nights. That sounds a bit sad. Dance stuff. Ooh. Not sure about this one. Alright. Lift, drag, drop. Lift, drag, drop. Lift, drag, drop. Lift, drag, and drop. So, the delta vector in this case is... yeah, we don't want the card Z whatever. We want the board Z. And we don't care about the delta. We'll do it, no matter what. So I think on drop we don't snap, right? Drag finish, animate vector. On drop, drag finish, animate vector. Animate vector, lift vector. No, we don't snap on these. Okay. We don't snap on drag, but we snap on drop. So, whoop, whoop. Animate vector done. Delta vector. Delta vector. This is the drag or the drop? The drag or the drop? So currently the drop doesn't come through. Okay. Lift, drag, drop. Card, drag, card, drop. Message target. Lift. Lift it. Drag. Drop. Lift, drag, drop. Drag, drop, target, drop, target. Okay. So screw this. Screw that. Screw this. Screw that. Drop. Drop it. Ah, yes. We gotta do it because the cards, the delta vectors. Anyway, gotta do with that. Drop. Okay. Now, card drag proxy. Did I just mess that up? Cardboard Z. All right. Okay. Now, when we're dropping it here, the wireframe gets a. Now, the wireframe we don't actually want to use for this one, so let's not use it. Let's skip that. Skip that. And the wireframe should really only be used by the client, so we don't get confusing signals. Because of course we have a second mouse here, and it will do its own things, right? Ah, you see? Interesting. Object on, not on instance of 3. Did I miss a use of the word wireframe here? I think it's this one. So, lift. The animation is too fast now. Drag. False. Drag and drop. XenoCard 3D. So, the snapped animation timing is 0.3 right now. So if I make that slower, I should be able to see if I'm using the right animation. So that's slow. Ah! There's no animation here at all. It just jumps. Now, why would that be? So let's see. Drag. Delta 0, 190. Drop. Drag. Drag 230. Drag 230. Delta vector. So the deltas here should be always only in the X and Y. But I pass in false. XenoCards 3D, animate mesh, false. Done like this. Wait, if snap is not equals to false, snap is true. Wait a second, what? If bar mesh, okay. If mesh tween dot kill. Fair enough. Okay. How's this? Delta vector, animate mesh, V. So that was a 230 up here. And snap is false. If snap is not equals to true. If snap is not equals to false, snap becomes true. If snap triple equals to false. Then duration 1.3, power 4 is in out. Okay. What the f... Now I bet if I make that longer, then it will slide. No, it doesn't slide. The hell? Mesh vector. Mesh between animate position, move vector, duration using done. Mesh between animate position. Mesh vector. Move vector. Sub move vector. Drop. Delta vector. Okay, so we've got a vector and we're trying to move by it. But somehow that movement doesn't really seem to work. Why? Okay, so drag and drop. Sorry, here. Blueprint client. Let's get rid of this for a second. So, get rid of this. So, drag. I removed the delta vector length check. Why? Oh, I got a bit. Okay. Alright. Alright. If delta vector length is greater than 0.01, then otherwise don't. So make debugging a bit easier. Don't want to move the wireframe here. The wireframe is a client-side thing. And the wireframe should probably be handled inside the drag and drop thing. It's a UI element, right? Wireframe? Here. Oh, probably because the tween was instantly skipped. Oh. Uh-oh. Ah. Okay, no, that's a flaw in the animation system. So when we're killing the tween here, when we're killing the tween here, where will we be at after we kill the tween? So, console.log mesh.position. So, as I'm moving it, at the end it got killed, right? Mesh.position.clone. Mesh.position move vector. Like it's instantly jumping, right? Yeah. After we kill the mesh. Mesh vector, animate position, move vector, mesh dot position, clone dot negate. Because the problem is right now, here we lose whatever delta we had before. So the point is that if we're going from A to B to C, and on the way from A to B, we cancel the animation and want to go to C, we don't want to eliminate the animation altogether. We want to pause halfway between A and B, and then animate from that position to C. The problem is to do that, we need to know what A was, which we don't know, unless we record the previous move vector. Which technically is recorded as part of the mesh tween, isn't it? I think it's part of something in here. It is either vars ooh, excuse me. Ooh. It's vars or target. The problem is I don't know if var. Oh shoot, we're really just animating. T. I think. Animate position. Ah, shoot. Yeah, we're not actually animating the position here. We might be able to change this though. Let's try this. So instead of doing this, what if we directly animate position, right? And then our target, instead of being 1, is going to be x, is going to be position.x plus vector.x yz, right? And then we don't actually need this. This doesn't make any sense suddenly. And OnComplete is literally just like a reference to done, right? So we can just say var anim equals this, right? And then we can say if type of done anim dot onComplete equals done, and then we'll just pass in the animation here after duration, and that's it. Now the only problem here, of course, is that the position, it's a relative animation, the position doesn't get updated when we're interrupting the animation. But that's something we can basically fix here now. So, so what happens here? Mesh.position isn't updated. We want to add mesh.position to the delta of the next animation, right? So animate mesh. Right, so boom. Now the first one here is this. Animate mesh. Don't actually want to do this. Animation killed. 1, 2, 3, 4, 5, 6. So if an animation gets killed, I want to know what the difference is. So animation got killed, the z was minus 1 to 8.3, and afterwards the z was still minus 1 to 8.3. So basically what we then want to do is we want to say move vector dot add mesh dot position, and then mesh dot position dot set 0, 0, 0. Right? Or the opposite? Yeah, the opposite. Sub. The problem is the easing in this case. because it re-eases. Kind of pauses instead of smoothly continuing to the next one. I think I've struggled with this before. It's probably just a question of taste, like what feels better. Kind of pauses every time I change targets, which may or may not be what we want. And if I don't snap, which is happening here, if I don't snap, you might not even notice it because it's just too quick and there's no easing issues. Then if I bring in the second mouse cursor, right? Oh, I can't click with two mice at the same time? Ah, but I can move two mice at the same time. I'm getting dizzy, getting cross-eyed. I'm gonna have to set up like a simple VM or something. Thanks, man. But it's starting to move smoothly. Now, yeah, so this guy has his little bouncy kind of, hey, this is where you're gonna drop it. And this guy has his own bouncy droppy thingy. Kind of cursor selector. And it shouldn't care about perspective now. Yeah, exactly. So here we have crazy perspective, but on the left side, he doesn't care what your perspective is. He just shows you your intent. And that's the whole point of this. The whole point of this system is to give a hint of intent to the second player. Ooh. It does mix up the selection sometimes. Okay, yeah. It's probably because I'm just running two clients on the same computer where it causes problems. Yeah. I mean, it's a pity that we can't do the ease in out. The only thing I could do is I could, if we're interrupting an existing animation, then we automatically enable snapping. So if this is the case, then snap equals true by default. Because we don't really have the time. Either we do that, or we just manipulate the easing, right? So if we move all of this stuff, mesh position.clone negate. If we move this up here, right? And then what we can do is we can change easing to be ease out instead of snap equals true. And then we can use false here for the snap. So it'll still move a bit smoother and it'll still do an ease in, but it won't re-ease in the middle of trying to catch up. And it'll lag a little behind, but of course this is going to happen for two different people on two different computers, and they'll never know. And the cool thing is, we still have independent server state. No, we don't. We don't have independent server state right now. I'm an idiot. So we're not actually modifying the server state. We're not actually modifying the server state. Alright, so now the server actually has to listen in as well. So as we're dropping the card, yeah, we might not actually wanna, yeah, so the drop we might not actually want to pass through. We might want to handle that through server state updates. So right now we're passing drag finish from here, but the reality is, the server is supposed to have a say in this, right? Oh yeah, that's up here. No, that's in here. I think there's no other logging, right? Okay, animate vector done. Animate, create card, animate vector done. Don't really need that right now. Yeah. So we're updating the client views, but we're not updating the server state. Maybe instead of moving the card, we should literally just move the selection. Or like have a shadow card that we're actually moving, like the green wireframe, that's what we're actually moving perhaps. Also we have a delta vector being spammed in here. From lift, okay, fair enough. Okay, so so when we're dropping the card, we want to listen to it on the server basically. Okay, so player blueprint is gonna have to do some work on the server. So player blueprint server. Drag 1, unhover 1, okay. So we don't really want to listen to all of these. We want to listen to some of them. And the default is to send it through, or at least the case for a bunch of these, right? So hover, unhover, case, hover, colon, switch. Right. Default. Right. Break. So the hover works. When I pick it up, that should work as well. Lift, drag. So hover works, pick up works, moving it around works. Now when I drop it, it doesn't actually drop it here. Now on drop, we should have gotten this, except we're currently not forwarding drag finish, right? So if we do drop, we'll send it to the server, but the server doesn't forward it. The server is gonna make some decisions, right? Now, right now, there aren't many decisions to be made, but obviously when you're playing a card game, this is basically when you're executing your move, right? So, drop. Now, what we're doing when we're dropping, we're basically updating server state. And in this case, it means we need to access the server. And the server is basically our server blueprint, which has a bunch of cards, and we want to update them, right? So network client server dot cards dot length, I suppose. Server cards message dot card. So the question is, can we now pinpoint the specific card that was updated on the server object? All right, let's reload it. Reload. Here we go. So we're moving this and we're dropping it here. So there's 14 cards, and the specific card we wanted to move is the one that used to be in this position. So, hey Ronaldo, how are you? Oh, thanks for the Xenocide Alpha subscribe, guys. Thanks for the follows. Appreciate them every time. Plans for June. See Cloud and DevOps World in London with a VIP pass. If you pay for the flights, sure. I'll take a VIP pass. Okay, 1 second. Let's try it one more time. Okay, so YouTube slash live dashboard. Shorten YouTube link. You can have a share button underneath the live stream. It shows my stream is offline. Why? Is restream messing with me again? Unknown, it says. Well, the stream, it says it's offline. Alright guys, 1 second. I'm gonna restart the stream. It'll take like a minute max. 1 moment. Alright, so that's the share link. The stream's still offline. Restream doesn't seem to be wanting to stream. LCTV should be up and running in a second. Let's check Game Dev Network. What a load of crap. What a load of crap. Alright, let's try it again. So, segregation, problem. XenoCards, CCG engine, HTML5, WebGL, and .js. Start streaming. And nothing happens. Once again, nothing happens. Why is my live stream not working? Wait a second. Was that the wrong YouTube stream now? What's the difference between YouTube and YouTube stream now? I have no idea. Okay, I'm gonna restart.